In some situations, the equation that we have doesn't look like a quadratic equation. It doesn't have an x squared, an x, and a constant term. But if we manipulate it, if we, for example, multiply each of the terms by something, then perhaps we can get a quadratic equation, and then it would be easy to solve. And this is an example of example 10. So in order to solve this equation, we've got to multiply each term in the equation by the lowest common denominator. And in this example, the lowest common denominator is 3x times x plus 1. Now look what happens when we do that. When we multiply each term by 3x times x plus 1, what we get is something that looks like this. Now you'll notice that the first term, that 1 over x plus 1 term, when multiplied by the LCD, means that the x plus 1 and the x plus 1 will cancel out. In the second term, the 1 over x term, it's the x term that cancels out. And in the third term, the 4 over 3, it's the 3 that cancels out. Now that should mean that when we simplify this term here, that we get 3x, and we get over here 3 times x plus 1, and over here we're going to get 4 times x plus 1, so 4x, x plus 1. And here we have it, so that's 3x equals 3 times x plus 1 minus 4x times x plus 1. And if we simplify that, we get 3x equals 3x plus 3 minus 4x squared minus 4x. That's just multiplying out the brackets. And if we continue a little bit with that, we get 4x squared plus 4x minus 3, which then simplifies. You can factorize that. It takes a little bit of time, but you get 2x minus 1 times 2x plus 3, all equals 0. You can solve that so that you eventually get x equals a half, or x equals negative 3 over 2. Now, it's quite important that you check your answers actually work. So sometimes when we go through the process of solving an equation, we introduce extraneous solutions that actually don't solve the equation. They're just solutions that the method has produced, and they don't actually work. So we should test x equals a half and x equals negative 3 over 2 in the original equation. So if we try x equals a half, then what happens is we put it into the original equation, and we eventually end up with an equation way over here on the right, which actually is true. 2/3 is equal to 6 over 3 minus 4 over 3. All that's happened is that a half has been plugged into the original equation. Remember, it was 1 over x plus 1 equals 1 over x minus 4 over 3. And so all that's happened is that we've simplified that. 1 over 3 over 2 is 2/3. 2 is the same as 6 over 3. And look, 2/3 is the same as 6/3 minus 4/3. If we try x equals negative 3 over 2, I wonder if this one will work. If we try it, it does seem to eventually work. Again, just put in negative 3 over 2 in place of x in the original equation. When we simplify this, we get negative 1/2, negative 1/2. 1 divided by negative 1/2 is negative 2. This part here, 1 divided by negative 3 over 2, becomes the negative 2 over 3 that we have here. Now we just flip the negative 3 over 2 upside down. These become negative 6 over 3, and this becomes negative 2, and we end up with negative 2 over which is the same as negative 6 over 3, so it does actually work. So both of those values, x equals a half and x equals negative 3 over 2, they both work. Now that process of checking your answer in the original equation is especially important if during your process you have to square both sides. You'll see here that if you have an equation x equals 3, if you have an equation x equals 3 and you square both sides, that's x squared equals 9, and it turns out that there are two solutions to that, right? So this x equals negative 3 had nothing to do with the original equation, but it's been introduced because we've squared both sides. So we're going to have a look at this equation, 1 plus square root of 3x plus 1 equals x. Now the first thing to do is to isolate the square root, to get the square root by itself on the left-hand side if possible. And we do that just by moving the 1 over to the other side. Now, once we've got that, we can square both sides to get rid of the square root symbol. So if you have a look at that, this part here has been squared to get 3x plus 1. The x minus 1 has been squared to get this thing here. If we now expand the x minus 1 squared, that gives us x squared minus 2x plus 1. We can simplify that by moving the 3x plus 1 over to the other side. When we simplify, we get x squared minus 5x equals 0. We can factorize that. The x squared minus 5x becomes x times x minus 5 equals 0. Now that has two solutions. You could have x equals 0, or you could have x equals 5. That isn't quite enough. We still have to check that those two answers actually work. So we try plugging x equals 0 into the equation to see if the left-hand side is the same as the right-hand side of the equation. So we're putting x equals 0 into this equation in place of x, and then we're seeing if the left-hand side is the same as the right-hand side. If you have a look at that, when we calculate the left-hand side turns out to be 1 plus 1, and that turns out not to be the same as the right-hand side. So that tells us that we should reject x equals 0. If we try x equals 5 in place of x, then we get the value 5 on the left-hand side, which equals 5 on the right-hand side. So in a case like that, we accept that solution. The only solution is x equals 5. Now there's one other type of equation that might pop up, and that's this type of equation here, the 2x to the power of 4 minus 6x squared plus 3 equals 0. It's not quite a quadratic, but it's a little bit like a quadratic. In fact, if we put y equals x squared, then we're replacing the x to the power of 4 with y squared. We're replacing the x squared with y. And so we'll end up with a y squared and a y term and a constant. And we will have a quadratic. We'll have the quadratic 2y squared minus 6y plus 3 equals 0. And then if we use the quadratic formula to solve that, with a equals 2, b equals negative 6, and c equals 3, we'll get something that looks like this. Then simplifying that, we'll have 3 plus or minus 3. That's for y, which was x squared. Now, we want to get x, so we need to take the square root of that, but it can be the positive or negative square roots of that. So if we try taking the positive or negative square roots of this, well, one option for that would be these two things, right? Notice that in these two answers here, we've used the plus here. You know, there were two possible values over here. We've just taken the plus, and we've noticed that we could have a positive square root before it or a negative square root before it. That's not the only possibility though, because we could also have from here 3 minus the square root of 3 all over 2 and take the positive and negative square roots of those. And in fact, that's what's happening next. Right? These two values here are the positive and negative possibilities for that. So there you are, 4 solutions for that equation. That's often the case if you have something that's which has its highest power of x being x to the power of 4. Quite often you'll have 4 solutions to that equation.